Hello there and welcome to this course. My name is Valentine and I'll be your instructor. In this course, we are going to start by learning the learning outcomes of the summary course. Then after that, we'll get to talk about the original program, the concepts covered in the program that we're going to be going through a summary course for. Then we'll also talk about why you would want to learn about those concepts. Then after that, we'll go into an in-depth session where we get to practice extensively those core concepts covered in that particular program. We are not going to be using the content owned by the original owners of the program. Our focus will be generally on the core concepts, helping you to just be able to feel what it would feel like when you're going through such a learning experience. Then towards the very end, we'll just talk about the next steps. What would you want to do after going through a data visualization with Python program, or what else is there in terms of other programs like these ones would you want to also explore and get better and ultimately be able to work on projects and create impact within your organizations or within community at large. So let's get started. By the end of today, we are expected to have achieved these learning outcomes. So we should be able to describe the core concepts covered in the Moringa data science data visualization with Python program. We should also be able to comprehend or understand the limitations of the program itself, like what does it not equip you with, so that you now have a good idea of what exactly you need to now go and upskill yourself in. You should also be able to engage yourself in this particular course in an in-depth learning experience, delving into those concepts covered in that program, based on the publicly shared course outline that you would find about this program. That's the Moringa Data Science Data Visualization with Python program. Then towards the very end, you should be ready to undertake just basic projects in data visualization using Python. Those are the learning outcomes of this particular summary course. Starting us just generally to recap now, or to go through the actual original program which this summary course has been curated from. So it just generally gets ideas, or it's inspired by this particular program. So the Moringa Data Visualization with Python course is a course offered by Moringa School. It's a 12-week data visualization course, and that's designed for beginners who do not have coding experience. You also are required to have you're required to have some basic math skills, computer skills. So high school knowledge of maths should be sufficient. You should be proficient in English, both written as well as spoken, as the program is in English. And you also need to have a computer or laptop to be able to do the work that you need to do. It costs around $300. That's provided by Moringa School, and these are the learning outcomes. So by the end, you're expected to have a strong understanding of Python programming and hands-on experience with just key data science libraries such as pandas, which one would normally use for data manipulation, as well as matplotlib. And you should also be able to import, clean, manipulate, and visualize data sets, and be able to just identify just trends and also insights from just data sets using now visualizations. In terms of how it works, it's a 12-week program. So it means that you dedicate 12 weeks. Each week you would be expected to spend about 8 to 10 weeks. It's also online. There are live workshops, and you're expected to complete what are called just weekly projects, and also participate in one-on-one session with technical mentors or instructors. There's additional support that you would get if you were to do the actual original program. So that's just a quick overview, but one more critical thing to also get an understanding of is the curriculum that you would cover if you were to take that program. the program has been developed by Flatiron, which is another boot camp that's based in the US. So Moringa School uses their curriculum to and they redeliver it in this market. And this curriculum has the following topics. This is publicly available information. If you go to their website, you should be able to find this. So Python essentials, Python loops and functions, statistical measures, how to visualize data, data analysis in pandas, data cleaning in pandas, and also learning about APIs. So that's generally the curriculum. And the summary course will entail to take you through a journey that just equips you with these core concepts. We may not necessarily cover all of them. We would go deeper, but the idea is that you should be in a good position to say that you have a good idea of what the program entails. And if you want, you could always decide to commit to do the entire program. That's the one that's offered by Moringa School. Or you could even just use the knowledge that you get to also work on just basic projects that you get from this summary course. Our perspective, our review of the program is after work, which is usually important to just help learners what they're getting into. You understand based on the outline, the program itself covers fundamentals of data analytics, data science in Python. So learning about how to import data, how to explore data, how to clean data, how to analyze data. That is well covered, as well as also how to create basic visualizations based on the course outline that's publicly shared. However, there could be some sort of misleading title. So the program itself, it's not entirely on data visualization. So if you look at it, data visualization is actually covered in one of the topics itself. So just in maybe it's a module 4 out of 7, which some people might be thinking of going into this program hoping that they'll learn all the tools that there are in relation to Python, as the course title suggests. Learning about matplotlib, Seaborn, how to use Plotly, how to use Bokeh, how to use Dash, how to use Altair, how to use GeoPandas. There's so many data visualization libraries, and from the outline, it's not clear that the program tends to cover. And based on what you can see in terms of modules, one might say that it's data visualization is covered just a bit. So that could be a misleading title. That's data visualization with Python, but a suggestion would be it's more of an introductory to data analytics with Python learning experience. So so take that in mind. The other thing would be the target audience would probably need to have better or some Python experience if it's a data visualization with Python course. So that means if the program is just tailored towards data visualization, we would expect people to start off from day one just working on data visualization aspects, which of course requires that students learn a bit beforehand or do some pre-work on Python, and just doing basic data manipulation, data wrangling, data cleaning, and data analysis, just generally data preparation concepts before now undertaking an entire program that's focused solely on data visualization. So that way, when you leave off this particular program, you are visualization expert, you are data visualization expert who's really specialized in data visualization in Python. So that's one bit that one would think of getting from this program if it were a data visualization program, which seems if you join, you might get yourself with people who don't have any experience. So for experts who are just willing to just learn just data visualizations, this may not be the best course for you. There's also a lack of data visualization focus on libraries, as mentioned earlier. Thus, the program feels a bit too long. The program, I would understand some of these concepts you would cover in a matter of days, if not a week or two. Our recommendation is not really for the entire 12 weeks, but even 2 weeks for beginners should be sufficient enough. in terms of what we are going to be covering, we'll be covering actually basic concepts, the core concepts of this program within an hour. So you'll get to see, maybe you could actually spend a whole lot less of time just going through the core concepts. And I think I've repeated, a target audience would need to have just Python experience, maybe also a bit of APIs. The module included at the very end does not necessarily make sense, the APIs module, because that would be more of a data engineering skill that you would require in this program. So our summary course won't cover that. And not many organizations store data that allow other stakeholders to access that data through an API. Normally you'd hear about SQL, or even just people just sharing data that is in the form of flat files such as CSV and Excel files. But generally our overview, it could be that maybe this program is a lead magnet. So a lead magnet is that it introduces you to this learning experience at this institution. Then after the 12 weeks, once you have already had a good firm foundation of skills in terms of data analytics, then you can now commit to the extensive program that's provided. Maybe it might even be data analytics journey or data science journey. Data visualization journey would actually end up being a whole lot more than what we have. But yeah, so that's generally what we would think about it. So yeah, in terms of what we are going to be doing about it, in terms of the summary course that we'll go through, we'll actually go through the 6 out of the 7 different modules or 7 concepts. We'll go through 6 of them in a duration of an hour. Our target is an hour, but we'll try as much as we can to. But for you, because you will be working on challenges, it may take about 2 hours. And the course content that we've developed, we haven't gotten it from the owners. This is content that we've designed from scratch, or we've developed from scratch, and it's owned by Afterwork. So the idea is that this is something that this is knowledge that's publicly available, but we've organized that knowledge based on the outline that's publicly provided. And so we've also, you might notice that we've sort of disarranged or redesigned the learning experience, because the original program sort of takes you a bit around. It takes you, starts with Python essentials, then it goes into statistical measures. But something like statistical measures would require that you import data or work with real life data, and we thought, why not introduce something like data cleaning, so that data cleaning, and that would involve data importation. So that's once you've learned about data cleaning, then you get to learn about analysis, how to put data in the right format before analyzing it or before visualizing it. Then we also cover now the statistical measures and visualize data. So you'll notice that the concept of visualization will be covered towards the end, and that's what we are going to be building towards. We won't have a project for this, but if you're willing to learn a bit more, to get extensive resources from what we will have covered, we usually provide more challenges. So in addition to the examples for the concepts that we'll teach in relation to these particular modules, we'll provide challenges, but we won't provide all challenges for people who just want to see how the learning experience entails. But if you're willing to maybe invest a bit more, or just go a bit more deeper into maybe thoroughly understanding those concepts with more challenges, you have the option of becoming an Afterwork member, and you get just tons of resources at your disposal in relation to summary courses, in relation to other courses generally that we also produce on a weekly basis, and also we've also produced in the past. So you can opt also to become an Afterwork member to be able to get all the resources that you need. So at this particular point, I'm going to ask you to visit the link in the chat, so the resources link, and it should take you to a page that looks like this. And this will allow you to access the practice notebook that we are going to be using for this course. The sample note. So you will get the practice notebook, but this will give you a sample. A sample is just for people who just want to learn. And in the sample notebook, we have, as you can see, covered just the different modules that we have mentioned. For each and every section, we have just concepts that you would need to learn about that particular module. And if you go deeper into each concept, there's an example, an explanation, an example, and a challenge that you can be able to work on. So for those people who are just here for exploration, this is a good resource. But if you're here to learn a bit more, maybe you're a data science student somewhere, or you really want to learn data visualization in the shortest amount of time possible, we have provided a practice notebook and a solution notebook that provides you with even the solutions for the challenges themselves. So yeah, so the solution and practice notebooks are actually just copies, but for the sample notebook, it's a copy of the practice notebook, but with fewer challenges that you need. So yeah. That's generally it in terms of just a quick intro. So we are going to get started. So open that link and you should end up to this page, and let's get our hands dirty. We'll be a bit fast. If you feel like we are too fast, feel free to pause the video and rewind it, because it's a streamed video. So you could always rewind it and even ask questions in the chat as well. And if you feel like it's too even advanced, then you could always consider other programming, Python fundamentals, programming courses that we've posted on After. We have like 8 different, we have a series on Python fundamentals that covers just Python fundamentals for different sectors, whether it's manufacturing, banking, healthcare. So you could always explore that on our channel. And that's a good start if you feel like you still need to do something. So yeah, let's begin. So this notebook, a notebook is a document that data analysts or data scientists use for analysis. So we're going to start off by creating a copy so that we can be able to make changes to this copy. So go to File, then save a copy in Drive. So at the very top, you can pause the video, File, then save a copy in Drive. Then it should open a new tab. Then once it has opened a new tab, you should be able to, you can close down the original one. I won't do that because I don't want to create another copy. So you can open the new tab. I'll actually be using my practice notebook. And also if you're an Afterwork member, just use the practice notebook. So once you've opened that, you should have now a copy of the sample notebook and you should be ready to go. So for me, I'm going to open mine in playground mode so that I don't make changes to the original copy. All right, the next thing that we need to do is to connect our notebook to Google servers, because our notebook is hosted on Google Drive and we can be able to run our Python from this notebook using Google servers. So just connect to them. That's the easiest explanation I could give. Yeah, so, and starting off, you should see connected at the top and we should be good to go. Then let's start off by going through now Python essentials. We learn about the Python fundamentals in like 10 minutes or so. So when it comes to Python, it's a programming language. So it's a language that we can use to write code that performs specific tasks. When it comes to working with languages or programming languages, there are different programming languages for different tasks, like Python for data analysis, web application development, or even just desktop application development. So you can be able to create desktop applications, web applications using Python. You can use other languages for other specific use cases. You can use Java, even just also for desktop applications, even for data science applications. And also use Java for creating applications that run in mobile devices or just devices themselves. And there are hundreds of programming languages for different tasks. So Python is just this one that we can use for those mentioned tasks. For programming languages, they usually come with fundamentals, and that's what we are going to be covering. So how do we, the first statement is now to learn how to print out something. So we use what are called print statements to be able to print out some message or a value or other complex concepts that we get to know, such as variables, etc. So, and how we use print statements, a print statement is made up of a print function. So here, by the way, we have a code chunk, what contains this text over here is called, it's a code cell. Let's call it a code cell, and we are going to run it, and we're going to get an output. So this code cell contains comments. Comments is anything that has hash in front. So this is a comment, this is a comment. It means that Python behind the scenes won't run this line of code. So this there's a special program behind the scenes in where we run this, when we run Python code, and that special program that runs Python code is usually called an interpreter. So when we execute Python code, technically what happens behind the scenes is that the interpreter runs the Python code. So in this case over here, we are going to have these lines of code. There are 3 of them. So print hello, print welcome to, print Python programming. So let's run this cell, and we are going to print. So here, by the way, if I explain a bit further, print function, it's a function is a way of organizing code. And instead of, if we have hundreds of lines of code that performs a specific task, maybe we have 10 lines of code that performs this task of printing. Instead of writing that code, the 10 lines, we usually package the code and give it a name. So here we are calling the code that prints out anything that we give. So we give an input to a function and it gives us an output. So, and in some other situations, a function does not necessarily give us something. It usually just does a particular task that it has been designed to do. So here we call the print function, and we assign it, or we pass to it this particular input. We usually call them arguments. This is in quotes a string or some text. We want it to print hello, want it also to print welcome to, and Python program. So these are 3 different lines. So let's run this. If you get this pop-up, just know that you did not save a copy in Drive. So let's run that. All right, that's it. So the next thing that you're going to do is to work on this challenge. Just pause the video and print and create a program that prints out the text. A program is just code. Just write the code that prints out that. And you can pause the video, and then once you're done, we can continue. The solution to that, for those who might be asking, this is the solution to that. Moving on, variables and data types. We might want to, when it comes to working with programming languages, we tend to work with data. So we use programming languages to manipulate data. But in order to manipulate that data, we would need to store it somewhere. So we store that data in different types of containers. The most basic form of container is usually called a variable. So here we are going to be creating variables, 4 of them, one called name, another one called age, another one height, and another one is _student. And for each and every variables, we're going to assign it a value. So what's on the right hand side are just the respective values. So John, which is a string or text, will be stored in name. 30, that's an integer. It's a whole number, will be stored in age. 5.9 is a float, decimal point, will be stored in height. And true will be stored in is student. And then we display the variables. All right, at this particular point, pause the video and then work on the challenge. The solution to the challenge is what you're seeing here. By the way, I won't be showing the solution to the challenges throughout. It's only just for the first section. Moving on, basic arithmetic operations. So assuming that we have stored, as you can see here, we have stored the value 30 inside age and used this equal sign, which is, and it's usually called an assignment operator. So we store 30 inside age, height inside height. If we wanted to multiply age by height, then we use what are called arithmetic operators. So this is the addition, subtraction, division, multiplication, etc. So let's learn about them, but actually they're usually the same, by the way. So let's just learn about them. So there is usually the addition operator, subtraction, multiplication, division. So addition is usually just a plus, subtraction is just hyphen. And multiplication is just a star, and division is a /. So in our case here, we are creating a variable called result addition, and we are setting it to have the outcome of 5 plus 3. So here we can still have variables. We can still say age, then height, age, then height. and the outcome of this operation, which age will be what we had assigned here, 30 and 5.9. It would be stored in result addition, and then we can print out two things. We are printing out the first string. So with a print statement, we can print multiple things. So here we're just printing out this string, and then we are also printing out the value of result addition. But here, let me just revert back to what I had. So we also do the same thing to 10 minus 4, 6 times 2, and also 15 divided by 3. And for after each operation, we do the printing. So we'll see 4 lines, because the first one, the second one, the third one, and the fourth one, these are 4 statements. Let's run this, and you can see them. All right, pause the video and then work on the challenge. This is the solution to the 4th challenge. All right, moving on, type conversion. Sometimes we might have data stored inside the variable. So for example, in my case here, we have data which comes in different form. We have textual data, we have integers, we have floats or decimal points. In programming Python, we call it a float. And here we have a Boolean, has 2 values, true or false. So sometimes you might want to determine or to convert maybe some value into maybe an integer or a float. So assuming we had 1, 2, 12, which is a string, which is a text, Python we call it a string. If we wanted to convert this into an integer, 12, which is in the form of a string, to an integer, we can use what are called functions. Again, there are functions for that, and we can use an integer function, or an integer function for that. So let's do that. So let's learn how to convert now the value of a variable from one particular data type to the other. So here we have a numerical one. We have 1, 2, 3, and then we have num int, which is the variable, and we convert it into a string, so that now it has just a string, and we're using the string function, and we pass the string function. We pass num int to the string function, which gives us back a string equivalent of 1, 2, 3, and we store that in num string, and then we print out the both outputs. Okay, pause the video and then work on the challenge. You'll note that we won't go deeper into explaining or how to work with other types of functions for data or for type conversion. The reason is because we are not going, it's a summary course. So if you are really interested in that, you could always explore the original program, or you could always explore our afterwork program, especially Python fundamentals. Pause the video and then work on the challenge. Lists and dictionaries. So we've learned how to store one piece of information in one variable. So what if we wanted to store multiple pieces of information in one variable? Then, that's where we can get to work with what are called lists as well as dictionaries. So for example, here we have this, you can call it a variable, but now it's a list. Instead of calling it a variable, we'll call it a list. My list, we assign it this collection, 1, 2, 3, 4, 5. These are 5 different items, and we define them by using a left bracket, right, a square bracket, so the square brackets, and then inside we separate those items with commas, and we store them together in this list. And to access the elements of those lists, we usually consider what are called positions, like the first element or an item. So you can call the different items using the terminology element or item in a list. So the first item, we reference it, we can print out my list, then we say put square bracket, then we use the position 0. The first one is usually has position 0, second one 1, 2, 3, 4. So my list square bracket 0 will give us the first item. And you can experiment, you can play around. So that's a list. A list allows us to store just a collection of elements, but in some situations we might want to provide another dimension. So assuming we had some other information related to each and every element, like for example, we had some other information related to 1 and another one related to 2, then we can use what is called a dictionary. So a dictionary, we normally define it almost the way we have a list, but now we usually have what are called key value pairs. So in our case here, we have this key, and this has a value this, key and have a value this. So this is a key value pair, and we separate that with the next key value pair with a comma. And we use a curly brace for defining a dictionary. So a dictionary would allow us to be able to store more information as opposed to a list. By the way, if you feel like we're too fast, you can pause the video and you can also go through the explanations that we provided. All right, pause the video and then work on the challenge. Moving on, conditional statements. Conditional statements are a way of us being able to make some decisions based on maybe whatever value that we have in our variable. So assuming we had wanted to check which we wanted to check whether, you know, a particular value or item exists within this list or within a dictionary, or within just generally a variable. Overall, we can use an if statement. So an if statement starts with an if, then we say we have our expression. So initially we created our variable that has the value 10. Then we say if x, this is our expression, x is greater than 5. So we use the greater than operator. You can also use greater than or equal to. So this is equivalent to greater than or equal to. Let me even just zoom in a bit. Okay, this is okay still. So greater than or equal to 5. Then, so we terminate this list line there. Then we put an indent. So you can see that there's some indent over here. So it's double, but you can put just one to still work. So then we have now the code that we would want to execute if this statement turns to be true. And you can have multiple lines of code in here. You can also have another if statement to have what is called a nested if. And then if this expression turns out to be true, whatever that will be indented from if statement will be executed. If not, if this expression doesn't turn out to be true, let me just go back to so that I remove that yes. If this expression doesn't turn out to be true, then whatever will be in the next evaluation, that's the else, will be printed. So we have that as well. So yeah, so in our case, x is greater than 5 because x here is equal to 10. So x is greater than 5 will be printed. You can learn extensively about conditional statements, but that's again for the extensive or in-depth courses or the original program. All right, work on the challenge, and then once you're done, you should be good to go. Python loops and functions. So sometimes you might want to go through the elements. So assuming you wanted to get the first element in a list, or second or third, and do some operations to it, then we can use what are called for loops. So for example, the most basic type of way of going through or iterating is usually called a for loop. You might compare it with a bit of some if statements, but here we don't use if statements. So here we are going to be using, we first of all define the collection that we want to iterate through. So we use for is a keyword, then the variable that will hold the current item, and then we use the keyword in, and to define then later the collection that we want to go through. We want to go through this particular collection. This can be either a dictionary, can also be a string, where you want to iterate through other characters. Then we go for each iteration. So we'll be going through each iteration. So the first one, second one, third one, fourth one, fifth one. So for each iteration, we are going to be updating the value of num. So that value of num in the first iteration is 1, etc. And we're going to be printing out whatever that is indented, or running the code that will come in the area that's indented for the for loop. So we're going to print out 1, 2, 3, 4, 5. All right, work on the challenge, and then let's continue. Moving on, while loops. So for loops iterate through everything, but while loops only iterate if a specific condition that you've set is true. So you can think of a while loop and it has some condition that you have. So let's go through this. So initially, assuming that we have a while, so we have this variable, and a while loop will define first of all the condition that we want to. While num, this variable, is less than or equal to 5, So right now it's at 1. Then we will execute the body. So we will print out the value of num, and then here we are using what is called an increment operator, which is similar to num is equals to num plus 1. So it's like just this expression that you see there, it's just like writing something like that. So but programmers make it simpler by using an increment operator. And yeah, so we increment. So we would increment the value of num. So in the next iteration, num will be 2, and it will be printed. Then we go 3, but again, we are still also for each iteration checking whether the condition is true. When we get to 5, then we try to go to now. When we increment 5, it goes to 6. We try to go to 6, then we will get it actually will not execute. The while loop will stop. There are further concepts that we can get to explore. We can also have for loops inside while loops. You can also have if statements inside while loops, etc. But those are just for complex cases. At this particular point, pause the video and then work on the challenge. Inbuilt functions. So far we have been working with actually inbuilt functions. Like print is an inbuilt function. So already code that has been provided at the core, like for doing just basic tasks like printing, has been provided, and we can access that code through the use of inbuilt functions. Let's say, for example, we have this list and we wanted to determine the length. There is already an inbuilt function called len that allows us to determine how many items are in this list. And then we store that there, and then we print out the length of that list as shown. All right, there are many inbuilt functions, and we'll get to interact with quite a large number of them. There's max, min, sum, etc. At this particular point, pause the video, and then we can continue and work on the challenge, and then we can continue after. Functions and parameters. So far we have been able to work with inbuilt functions, but we can create our own function. So we can create our own code, package it in the form of a function, give that function a name, and then print out whatever that we want. So in our case here, we are going to have this function. This code is the one that we want to print. We define a function using the def keyword, the name of the function, and this function will take an input called name, and inside, once it has gone inside the function, so we will print hello, then plus the name itself, this text, and then yeah, and that's it. So how to use this function? We just use greet, then Alice. This will be passed now to the function, so it will be hello Alice. All right, pause the video and then work on the challenge. All right, that's the first section. Then we'll move on to our second. It's actually 1, 2. Okay, all right, we've covered second section, so we are moving into our third section: data cleaning with pandas or in pandas. Now, when it comes to working with, let's say, Python for specific tasks, we can write code from scratch, but we don't. We usually use what are called libraries, which are now just the functions. It's code that has been written by other people who have tested it in production, and they've packaged that code in the form of functions. But now, again, they have repackaged it in the form of what are called modules, and then modules actually make libraries. So in a library, you have modules, and modules you have now just different functions inside those modules. So we are going to be using pandas, which would provide us with code to perform data manipulation or data cleaning tasks. So the first concept that we learn, how to load and explore data. So assuming we had this data set in this location, so we would use the read CSV function from pandas. So any place that you see PD will actually be referencing pandas. So we use the read CSV function from pandas. We pass to it the location of our data set, and the outcome of that, we store it in df. So yeah, run that. When it says check, when it shows check, it means it's run well. Then we can display the first rows of that data frame. So technically, the variable, once we've loaded a data set using pandas, we usually call that variable a data frame. So here we're just calling it df. You can give it any name. But then we can apply another function to df, the data frame, called head, to be able to display the first rows of the data frame, to just get a good understanding of the data set. Then we can check the shape or the size of the data set. So we'll check rows and columns. So we'll get a tuple or tuple. So this is 100 rows and 7 columns. So we can also check the data types, like to just see which classifications they are. We mentioned we have integers, strings, In Python, we by default integers are given in 64. Strings, it's usually object. So here, this employee name has an object data type. Salary, experience, int, and location object. We can also get a statistical summary of the numerical columns to just understand. Like if you see maybe the values over here. So these are just for the numerical columns, not for the text ones. This is analysis. If you see here maybe 99, 98, maybe you know that if these values, the count values are not equal for all the variables, then you have missing values. All right, pause the video and then work on the challenge. Cleaning columns, sometimes you might want to clean the columns. Maybe you want to lowercase them, or even just for, let's say, employee name, we want an underscore in between employee name. Then we can clean them. Like, you can decide to replace maybe the space, like which we are going to be doing here. We load, this is a new data set, and we print out the columns before cleaning and also printing them after cleaning. So we replace the spaces with an underscore. We use str, and we reference the columns in a data frame by saying df.columns. So we get them and then apply str.replace function, which takes in the following arguments or inputs. You can, in Python, call them arguments. So the first one will be the value that we want to replace, and the second one will be the value that you want to use to replace with. All right, and you can see this is what was printed here, the employee name, and the employee name here has an underscore. Pause the video and work on the challenge. Data type conversion. So sometimes you might want to convert a one column from maybe integer to float, float to integer. So we are going first of all to load our data set, then print the current data frames, data types, and then we are going to convert the price column, which is from this data frame, to a float from whatever data type it's in. So we will use the as type. So we'll reference the column name by saying df price. Then we apply as type function, and we give this as type function the float value to be able to assign now a float data type to that column. It makes sense. Price usually has decimal places depending on the currency that you actually many currencies, almost many. So we also do the same thing. We also convert a sales quantity to integer, and total sales to float. And you'll note that initially these are the original ones, and you can see for price we had int, and here we have float. For sales quantity we had int, and here it's still the same. Total sales we had int, and here we have float. All right, pause the video and then work on the challenge. Handling missing data. Sometimes you might want to check, the missing data in our data set might have an impact, a significant impact if we use it for analysis as it would be. So we would need to handle it. We can check for missing values as shown. Using the df, actually we apply the isNull then .sum functions to the data frame that we are working with, and this would just give us an analysis of the columns as well as the number of missing values. And once we've determined that, we can now decide to fill in missing values, let's say with an arbitrary value of 0. This is only based on domain knowledge. Then we can check again for the missing values, whether that operation happened. We set in place to true so that our changes here for replacement of missing values is applied to the original data frame. Otherwise, you'd have to say df is equals to, and then you can just remove in place. But let's not do that. Here you can see the first, the missing values from here. So these are the missing values, this, but now here we don't have missing values because we've replaced them with zeros. Pause the video and then work on the challenge. All right, moving on, data analysis with pandas. So we're going to learn a few things. So how to select data from maybe a data frame, like specific columns. So let's load our data set. If we only want to maybe work with only some columns. So maybe sometimes you don't want to work with all the columns here. So we might want to work with just a few instead of maybe tens or hundreds. So we can select the columns that we want by simply referencing the data frame, then using square brackets, then giving inside that square bracket, we give it, we also set a list of the columns that we want. Let's say product, price, salesperson, and regions. region, so which are correspond to the columns here. But you can always even select one by just going that route, as you can see there. All right, so we can preview the selected columns. We just preview them, so we can still apply the functions, the ones that we had earlier, to just get an understanding of what we have. Pause the video and then work on the challenge. Filtering, sometimes you might want to filter for records maybe that belong from one region or something, based on whatever that we would want. There are many techniques that we can do. We even have a course on data filtering, a 1-hour course that takes you through all the techniques that you need to learn about pandas and Python. But here we're going to just cover one of the simplest techniques. So here, let's first of all preview our data set. This is what we have. If we wanted to get the records with category equal to electronics, as well as price, and we use and price is greater than 500. This is how we would set that particular condition. So we use the data frame, then we apply a query function or query method, usually call it query method, and we give our expression. Expression, we would need to put it in quotes. And we define the category with the column is equal to, is usually double equal sign, electronics, and this is another expression that we want to also check. But if you don't, you can use or if you want to check for single ones, or alternatively, if you have multiple words in a column name, you can just enclose them in delimiter characters. Let's say category, like that, the column names. But if you have single word column names, then this should be good. And if you don't need a second expression, you could always just leave it like that. All right. Remember to always enclose your strings, the ones that you have, the object ones that you want to check in quotes. All right, pause the video and then work on the challenge. Sorting, sometimes you might want to sort maybe a data set. So maybe let's load this data set. You want to sort the records in ascending or descending order. It could be data set that you already have, or that you have maybe records that you filtered. You could always do the same thing. So to do that, we usually apply the sort method or function to the data frame that we have. It could be the filter data frame or just the original data frame. So in our case, we want to sort by price in ascending order. So by price in ascending order, so you want the smallest to the largest. By default, you do not necessarily need to put this ascending is equals to true, but we are going to set it to true because by default, it's usually set to true. And then we preview that. So let's run that. We should be able to see price starts from the smallest and it continues to the largest. So if you want to do the descending order bit, you just change true to false. Pause the video and then work on the challenge. All right, we might want to group our data. So initially we might have this larger data set, but we only want to create a smaller table that has category and the total prices for each category. So that's a summary table. There are two ways, actually, three ways you can use, you can create summary tables with Python. There's, we can use a pivot table function. I think there's also crosstab, not sure. But yeah, can't remember, just concept I did a long time ago. So grouping, but we can also use group by function. So let's load this data set. This is the data set that we have. We want to create a smaller table of region as well as the sales amount. So for each region, we want the total sales amount. So you have a smaller table that we can even decide to create a bar chart for on. So initially, so here we can decide to use a group by function. We use the data frame name, then we apply the group by method. Then we use the group by function. We use the, we define the column that we want on the left-hand side. That's the region on that summary table. And then on the right-hand side, we use square brackets and say sales amount. That's what we would want to perform a total of. So, and then we apply the function that we want. So in our case, we want region and the total sales amount for each region. If it was maybe average, we would use the average function over here. And then that's it. And we, okay, or before we even do it, we also usually apply this reset index. We can apply it here, but reset index just ensures that our output is in a data frame format that we can again apply pandas techniques to. So it looks like this. If without reset index, it would look like this. All right, at this particular point, pause the video and then work on the challenge. And if you're an Afterwork member, remember to use the solution notebook to verify your solutions. All right, statistical measures. Sometimes you might want to calculate maybe mean, sum, or minimum, maximum. So we just cover a few to just give you a good idea. So we might want to calculate maybe the mean of a column. So we would maybe want to calculate maybe the mean of price and store it in a variable. So we can reference the column that we want to work. Then we apply the mean function. So this is what we are doing to apply to the mean function. And then we store the output of, which is now the output or the mean of price column inside mean price, and we can print it out. The same case, we can do the sum. We can also do median as well. So let's run that and we'll see two values that we need, mid and sum. Pause the video and then work on the challenge. Remember, by the way, you can also do the same thing. These functions, you can apply them to filtered data. So once you filter data, you can always just apply those to that data frame that you filtered. Calculating mean and max, it's almost the same, only that here we are using mean and sum. Now you can use just mix mean and max functions and yeah, we'll do that. All right, at this particular point, pause the video and then work on the challenge. If you're an Afterwork member, remember to verify your solution so that you're able to know that you're doing well. All right, lastly, how to visualize data. So sometimes you might want to visualize data. Actually, that's the core of this, the value proposition. We followed the outline of the program. So, you know, we won't cover everything. We'll just cover the basic visualizations. Yeah, so bar plot. But you know, we're going to cover bar plot, pie chart, line graph, histogram. We're using just, we're assuming that, you know, this is what learners get to go through in the program. And that's what we're going to be covering. But again, if you want to go through extensive learning, an extensive learning experience, then you can go through the actual program. So we'll import, just as we did with pandas, we now have another library for data visualization. So we can, instead of writing code to, let's say, from scratch to create a bar plot, pie chart, and line chart, we can instead use code that has been written. So we are going to import the matplotlib library, which is usually the most basic standard library that we can use when it comes to working with data visualization. So if you want to create a bar chart, etc., any basic chart in Python, we normally would work with matplotlib. So here we're importing matplotlib.pyplot. We don't want to import the entire matplotlib library because it won't necessarily give us everything. When it comes to computing, efficiency is key. So we are going to import the pyplot module from matplotlib, and that provides us with just functions that we can use for just the visualization of basic charts. So, and we would want to use that module as PLT. Remember PD, pandas? Now we are using matplotlib PLT. So if you see PLT, just note that we are referencing matplotlib. All right, starting off, we're going to first of all work with a bar plot. We're going to create a bar plot, but we'll get to learn how to, first of all, prepare the data. I think we've gone through preparation phase. So what we covered earlier would have allowed us to get to this point. So we have this data set, and we would like to, you know, first of all, group it. So we will group it so that we can be able to create a bar plot from it. So we'll have a smaller table of category as well as total sales. That's what we have here. So let's run that. So we have category and sales, which total I mean because of the sum function. So we are going to create a bar chart. So initially, so we would decide to set the size of our function, of our visualization. We can say PLT, then we use the figure function, and inside the figure function we have this usually called a parameter. So fig size, we define the X and Y dimensions of our visualization. So you can play around with these ones, but the more, if you have 10, it means you have a longer horizontal dimension than as opposed to vertical. So but this one we just set 5 for. We want this visualization to be of this size. Then we use plt.bar. So this function would allow us to create a bar chart. So we would pass this input, or remember arguments. The first argument would be the category argument. So would be category, and now we give it the values that we want to have for that bar chart, and we can set the color of the bars themselves by using by setting this is in a function. You also have parameters, so we say color would be sky blue, and you can also change this to hex code or whatever that you want. Then we set the x axis label, so the title of the x axis, the same case with y axis, and you can also put like orientation, like you can, there's so many things that you can do, but most of the times we refer to the documentation for that. We set the title of the chart, and then we display. So plt.show just means display, but you can still use a colon, but let's just use the standard way. So yeah, let's, oh sorry, plt, we need to run this. Sorry, I did not run I did not import pandas, so no, in matplotlib, and I import it now. Right, there you have it. And there are functions, other functions that you can work with to just modify it. All right, at this particular point, pause the video and then work on the challenge. Pie chart. So we're going to learn how to create a pie chart. Let's first of all load the data that we are going to be working with. So we have that. That's the data set that we have. So on the labels, like, you know, the categories, it's like the labels themselves. You're going to have DA product, DA quantity, but you don't necessarily even need to do all of this. You can always just copy this and paste them inside where you're going to be using. So once we have prepared our data, we just copied our product data in this the labels variable, in the same case with sizes variable. Then we set again here the size of our plot. Then we use a pie function. Remember, in the bar chart we use the bar function, so here we use a pie function. Then we say sizes would be now quantity of what we want. So here it's slightly different, so we have the numerical values going as a first argument. Then labels, we set labels equals to labels, and then auto PCT just refers to we want one decimal place in terms of percentages showing up. And also we define which our start angle, like we rotate our chart to start from a particular point, which you can always do. And you can always even, like, it's usually called exploding. You can like segment one area in a chart that you'd want. Axis, we can just say equal if you want. It doesn't really matter, but yes, axis, you can just set it as that, title and show, and we display it. So yeah, you can see how it looks. But even equal, you do not need equal. You can just run it like that, and you can get now your visualization. To save it, there's always a way of saving it, but there are many ways of saving it, even just going behind the scenes and saying file save as. All right, pause the video and then work on the challenge. Line chart, almost as close as pie chart, but now we use a plot function. So let's load our data, the data that we need. Plot, then we give x on the x-axis, y-axis. Then for the markers, we want for the line chart for the different low or high points to have zeros. Color of the line chart, the style to be a line, the width to also have 2, and we set other information. We also set a grid to be shown, a grid boxes, as well as the orientation of the x values. So the x-axis, the values we want them to be rotated 45 degrees. All right, pause the video and work on the challenge. All right, lastly, histogram. We can create a histogram to understand the spread of the data. So we would want to understand the distribution of numerical data. So we can use a histogram. So we set, let's say we're interested in profit, want to see how spread the values are. Are they spread towards one side or the other side? It's useful for analysis, or even just machine learning model data preparation. So use histogram, we set the variable. Histogram only works with one variable. Then the number of bins, the color of the bins, as well as the color of the edges of the bins, and then we set the other information. And that's it. Pause the video and then work on the challenge. All right. So there you have it. There you have it in terms of a learning experience that takes you through what we have covered. We hope you are able to go through the entire summary course in the shortest time that we were able to provide. We understand this is not an extensive learning experience. For that, you can always consider going for the original course, that's the Moringa program, or even just going for the after work courses. We have courses focused on data analysis or even data visualization, whatever that you think that would be important to you. So that's it. If you loved this experience and you want to tell us that we are doing something good, be sure to give this video a thumbs up. And if you'd want to be informed when we post such future summary courses for other programs around the world, follow us and subscribe to this channel. All the best in your learning journey.